does for a loop. It's kind of a break for a loop. Get out, we're done, don't run that next line, get out. But it also allows the specification of what you want as the residual value in an expression. So we're doing a print, and then we're saying greet, and what's going to show up here is whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay? And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. We call the functions that return values fruitful because they produce something, and but you don't have to. You can just say return, or you don't even have to have a return statement. It goes to the last line of the function, and it does a return automatically at the last line of the function. So here's a little bit of a rewrite of our little language program. We are going to create a greeting program. We're going to take the language as the first parameter. And instead of just doing a print statement, which is what we did before, this is now more like a function because it takes some input and produces some output as a return rather than just printing. It's a little tacky for a function to print. And so here we return hola, bonjour, and hello based on the right thing. So now we say print greet en, so it runs the code once, lang is en, and then it runs this code, and the residual value is hello, so it says hello Glenn. And similarly, when it runs this code, it passes es in as lang, it runs through, and it runs this statement. It does, if there was more statements, it wouldn't run them. As soon as this return runs, that says that this bit right here is now HOLA, so hola Sally. And the same with French, goes in, runs again, out comes the return statement, and then bonjour Michael. So you see how we can control as we're writing the application, we can control as we're writing the function what the residual value that we want to see in whatever expression is calling us. Sometimes we have returns and sometimes we don't have returns. So if you think of the max code that we talked about before, we can kind of see that somewhere inside that max code there's a return, and that's how it communicates the W back to us. So we pass in as argument hello world, it comes in as a parameter, and it's going to loop through this imp somewhere. It's going to loop over and over into imp, and then at some point it's going to figure something out and tell us what it wants to send back to us is a return statement, and so the W comes back and gets assigned into big. You can have more than one parameter, and they're just in order. The first one and the second one, 3 and 5. So 3 becomes A and 5 becomes B, and away we go. So we just use this to add two numbers, and so 3 plus 5 is 8. So you get as many as you like, and the order matters. And if you do things like you tell it you want parameters and you don't give it to them, then that'll become a traceback, and it'll blow up. You can also talk about optional parameters later. So you don't have to have return values, and that means that you simply don't call a return with a value, and return is always implicitly happening as the last line of the function. So that's kind of the basics of how functions operate, but I don't want you to get too excited about writing functions. Some programming classes are like, gotta write a function, gotta write a function. Functions, to be clear, are a very powerful mechanism. And as we write programs, 150, 200,000, 200 lines of code, 1,000 lines of code, 10,000 lines of code, the concept of a function is really important. We would go crazy if we didn't have functions. But if you're only writing 20 lines of code, forcing yourself to write a function is kind of pointless. So don't worry about maybe the lack of urge to use this. We are calling lots of predefined functions, and we will for the next couple of lectures. There will be a time when you go like, oh, I'm sick and tired of repeating myself. Oh yeah, time to write a function. So that's why we don't push functions prematurely. We just want you to know what they are, use them, and at some moment you'll be like, oh, I want to define one. But don't worry about, it might take a while before you really want to define a function. So that kind of summarizes our lecture on functions, and up next we're going to do iterations. Hello and welcome to Chapter 5, Loops and Iteration. Now we're going to work on our fourth basic pattern of sequential, conditional, store and reuse, and loops and iteration. And this is the one where we teach the computer how to do things a lot. We can tell it to do something a million times. And so that's where we get the doggedness of computers, or the fact that they're so good at doing work for us because we can set them off to a task and they'll do it until it's done. So here's a very simple loop. Let's put the coffee over here. The keyword that we're going to start using is the while loop. We're also going to use the for later on. And the while loop functions very much like an if statement. The while starts it, and then this is just like an if statement. It's a question that leads to a true or a false answer. And then there's a colon, and then there's an indented block, and then we use the de-indent to determine how long the loop is, and so this print is de-indented, so that indicates the end of the loop. And so at some level, what's going to happen here is it's just going to run, and if this is true, it's going to run this code, and if it's false, it's going to skip the code. In that way, it functions like an if. The place that it doesn't function like an if is after it's run the code once, it goes up and then asks the question again. And so you can think of it going back up kind of to the top of the while loop and then re-asking the question, like, okay, is this going to run again? And then it's going to do that some number of times, and then it's going to finish. And so that's the loop, that's the iteration. And we're going to make a variable. We're going to construct very carefully a variable that we call the iteration variable, and that's n. And it's a variable that's going to change, and it's our way of running the loop, but not running the loop forever. So let's just run this. We come in, n is 5. Is n greater than 0? Yes, it is. So we're going to run this code. We're going to print out 5, then we're going to subtract 1, and then we're going to go back up and ask the question, is n greater than 0? And the answer is, since it's 4, the answer is yes. So then it runs again. Then it prints out 4, subtracts it again, checks, prints 3, subtracts it again, prints 2, subtracts it again, prints 1, subtracts it again. Now n is 0, and so it comes back up. Is this question has now become false? So it's going to take the exit. So it's going to come down and run this line right here. Then it prints blast off, and we can kind of print out the residual value of n just to sort of prove to ourselves that it ran until n was no longer greater than 0, and then 0 was the final value for n. And we carefully constructed this n equals, oops, go back. We carefully constructed n. We set it to 5, then we carefully subtracted 1 each time through the loop, and then we're using that to control when to exit the loop. And so you could think of this loop as, for now, running 5 times, true, 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 and then false finally. So this question was true for a while, and as long as it was true, the loop ran, and then when it turned false, the loop stopped. And so this variable that we construct to control the loop was called the iteration variable, because it tells how many times this loop is going to run over and over, or otherwise known as iterate. So this is a badly constructed loop with an iteration variable that we didn't do very well. And so if we take a look at this, we start out with n5, and then this is greater than 0, so it's true, so it runs it, and then it runs it again, and n is still greater than 0. So you can pretty much see, because we're not changing n, this is going to be true, 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 dot, 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 forever, true forever. And so this is an infinite loop, and it's just going to run until your computer runs out of battery, or you hit the button. This is the kind of thing where you often see your computer spinning like a spinning beach ball, or some other indication that your computer's super busy. It's in some kind of a loop, really tight, and it's running something, and it's using up all of the processing resources of your computer. That's an infinite loop. And so the problem is we did nothing with the iteration variable. Now here's a different loop. And so this one demonstrates a different idea. So in this case, we start out with n is 0, and it comes in here, and is n greater than 0? Question mark, and the answer is false. So it skips it. It doesn't run these lines of code at all. And so this loop doesn't run at all, because it comes in, asks the question, it says no, and then it skips right around it. So never run, never run. And so this actually is, sometimes you write a while loop on purpose like this, not quite as simple as this one, But the idea is this emphasizes that these loops are what we call zero trip. They are not even guaranteed